Antonio, welcome to KubeFM. So, for people who don't know you, can you just tell us about what you do and where you work?
Hi, Bart. Thank you for having me. Yeah, I'm working at Google and I'm one of the core maintainers in Kubernetes. My expertise area is in networking and testing, and I'm currently a TL for both SIGs. And I'm also during this year working on the steering committee. I've been elected last year, so I've been working on the steering committee of the project during this time.
Wow, very busy. And on top of that, you submitted a talk that got accepted as a keynote. Congratulations. Can you let us know
Thank you.
about what your keynote is going to be about? The topic so that people know why they should attend?
Yeah, well, the keynote is really it was a great surprise. It was a long time Kubernetes networking struggled to handle the low level networking. Right, Kubernetes networking is complex, but if you go into the, let's say, more traditional networking on telco, on now with AI/ML, all these complex RDMA devices and all the stuff, we didn't have the good APIs for handling it. So a group of people in Signal started to work this path to see how can we solve this problem, but how can we definitely solve this problem. There was several projects like Multus, several people trying different workarounds with custom resources, but there was not really a standardization on how to solve the problem. And we have a good relation with the people in the working group device management that they were doing dynamic resource allocation. And then we started to explore the problem and to try to understand the problem. And we realized that, okay, this is not really a network problem. This is more a device management problem, right? You have the network is represented as a network interface in the host. So we just needed to move these network interfaces into the namespaces. But in addition to that, there was this performance efficiency problem. There was not really a network problem too. It was more a scheduling topology aware scheduling problem. So with DRA and partnering with the people in the device management working group that were focused mainly on GPUs and accelerators and other hardware, we managed to get all these problems solved with standard API. You can use dynamic resource allocation to create what we call Kubernetes network drivers. That's a component that is able to expose the network resources as a service to the cluster. The user now can claim the resources in their pod, in their workloads, and the scheduler can make smart decisions to place these workloads so you get a good affinity intranode or internode.
And so this keynote's going to be given on November 10th. And it's a topic that you mentioned. Networking has come a long way in the history of Kubernetes. Last year we celebrated 10 years of Kubernetes, but when in our podcast in KubeFM, we've spoken to different people. A lot of people have identified networking as one of the more troublesome aspects of Kubernetes, one of the more painful aspects of Kubernetes that many people struggle with. For people that are out there, what are the questions that you get a lot about that? What do you find yourself, what advice do you find giving people most often when it comes to how to make networking easier on Kubernetes?
So that's a common and recurrent topic. And what I see is there are two patterns of people, right? There is the more application developer. That's what Kubernetes originally tried to solve, right? You just don't care about the network. You just deploy your YAML and the system provide, right? So you don't need to understand about what is a packet, what is a bridge, what is an interface. But when problems happens, they need to dig into the problems, and of course, they get lost because it's super complex connections of drivers and plugins and specs and load balances, and then it's when the other set of people that is the more, let's say, traditional networking background, then they go there and they say, okay, I don't fully understand how this works because Kubernetes networking model is very simple. They just say every pod should be able to communicate with each other pod without that, right? So that means that the system is a pure distributed system. And in traditional networking, you used to have subnets and routes and firewalls, so it's easy to spot the problems. So it's this mix between trying to hide much configuration details to the user and trying to have a distributed system that provides everything that conceptually is really simple, but at the implementation level it's really complicated because it's a pure distributed system for networking. And when you have a pure distributed system of networking, it's hard to troubleshoot. You don't have a beginning or an end. And as an example, you have one pod that fails to communicate with something. Where is the pod running? Today is here, but maybe the problem, the pod gets rescheduled or your workload changes or something, then you don't have the same failure. So that unpredictability of the system is what makes Kubernetes so hard to troubleshoot and to understand.
Much appreciated. And obviously, I'm sure we can have much deeper conversations about that. But for folks, once again, remember, Antonio's keynote is going to be on November 10th. Also, plenty of activity going on at the Google booth, which I believe is Google booth number 200. So you can have more direct conversations with him in person about that, about all the things that you're doing with the different SIGs that you're involved, be involved also in the steering committee. Antonio, thank you very much for your time and look forward to seeing you in Atlanta. Take care.
Yeah, thank you, Van. Looking forward.